This episode of Fluid Power Forum is sponsored by Endeavor AI. Endeavor AI automates order entry, quoting, and the quote-to-cash process. Win more, sell more, and save time, all without adding headcount. Head to endeavor.ai to learn more. This episode of Fluid Power Forum is also sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com. Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of the show, follow us on LinkedIn. You'll find us there at the National Fluid Power Association. And make sure to keep sharing those interesting and innovative uses of fluid power with our social media hashtag, #OnlyFluidPowerCan. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You'll find us on Apple Podcasts, on Spotify, on all the other popular podcatching services. Wherever you find us, please subscribe to the show and then give us a quick rating. Those ratings really do help promote the show and allow more and more of our friends in the industry to join in on these important conversations. My guest today is Philippe Reynolds, the director of Poclane Hydraulics' electromobility program. Poclane is a worldwide manufacturer of a wide variety of components, from pumps and motors to controls across the spectrum of off-road vehicle applications. This episode is one in a short series that we're doing on a recent white paper that NFPA published, Energy Efficiency Gains from Electrified Hydraulics. Philippe participated at a technology conference that we held at the ConExpo trade show on that topic, and we invited him into our forum today to discuss key ideas related to the electrification of fluid power systems. So Philippe, welcome to Fluid Power Forum.
Hello, Eric. Thanks for hosting me and Poclane in this very nice podcast session.
Yeah, we're excited to have the conversation. There's a lot of new things happening in the electrification of fluid power systems, and I know Poclane's been working on a lot of exciting things in that area. But before we get into those details, tell our listeners a little bit more about yourself. What is your background, and how did you find yourself working for Poclane?
Yeah, actually, my background is one of the transverse and cross-fertilized professional experiences. I'm an electronics engineer by education, but I have always worked in industrial companies in various positions, marketing, product management. I was also involved in sourcing for Poclane, actually, moved then onwards to business unit management. And since 2019, I'm now leading the electromobility business development at Poclane. I've been in the company for more than 20 years now. And my role actually today is really about helping Poclane evolve from a component supplier to a system partner, combining multiple technologies, hydraulics, electric drives, control software into coherent solutions that we are now pushing to the market to our customers.
Yeah. Well, I mean, your background and what you just described is really reflective of the cross-fertilization of technologies that's happening in the fluid power space right now. And that's very much accelerating. It sounds like you're helping to move Poclane in that direction.
Correct.
Yeah.
Yes.
And as go ahead. As
sorry.
Part of that, Poclane is, as you said, has been heavily involved in electrification. So tell us, how and why did that start for Poclane as a company?
Yeah, definitely. We recognized quite early that electrification was not a threat to hydraulics, but an opportunity to reinvent how systems are designed.
Right.
And in 2019, Poclane decided to make a strategic move and build a dedicated e-mobility organization because we understood this was a kind of different animal. And so progressively, we expanded our capabilities and competences beyond the hydraulics into electric motors, power electronics, and software. Today in the organization, we have in total 3 European competence centers with design and manufacturing capabilities. The goal is simple. We want to remain a power transmission specialist while delivering solutions that improve efficiency, performance, and safety in a new energy landscape, and be agnostic of the type of energy that the customer uses on their machines.
Yeah, that's again a lot of that's a testament to kind of what's going on in the industry. This agnostic approach to whatever the right mix of technologies is for the customer is what you want to focus on as an organization. There must be a lot of challenges that you have to overcome as you take that approach. What can you describe for us some of the challenges that you've run up against?
Yes, one of the biggest challenge actually is system complexity. Electrified machines combine multiple domains: hydraulics, electric drive, software, functional safety. Some of them are new, I would say, to most of the players in the field of transmissions for off-highway machines. And so you have to ramp up the competences and be really fluent in those technologies. Another key challenge is the energy management, how to optimize the efficiency, how to manage the thermal constraints of electric components, ensuring the right balance between performance, battery range, and the type of architecture. So architecture choice is really another challenge, trying to decide whether to go fully electric versus hybrid, depending on the duty cycle, the application, and basically the target cost of the overall system.
Right. Yeah, and there's almost an infinite variety of architecture choices when you think about it, right? In terms of this mix of technologies that you're describing. Maybe we can pivot and talk about some of the solutions that Poclane is developing and is offering. I know, as I mentioned in the intro, that you gave a talk at the ConExpo trade show recently about the role of mechatronics in that process. Maybe you can help us define that term first before we get into some of the details.
Yeah, from a high-level standpoint, yes, mechatronics, as we see it, is the integration of mechanics, electronics, and software into a single optimized system. In our world, where hydraulics are prevailing today, it means for electrohydraulic systems that a hydraulic component is no longer just a hydraulic, but it becomes a smart controlled subsystem, including sensors, embedded software, and connectivity. So this is a trend that we see more and more in the available and the new developments in hydraulic components. When considering pure electric solutions, this means smartly integrating electric motors, power electronics, mechanics, sensors, and software into a single optimized assembly that we generally refer to as an EDU, so electric drive unit.
Yeah, a lot of people have different names for that concept, right? There's a plethora of things coming onto the market that kind of fit into that category, but I don't know that they have a unified term yet for that compact system, if that's the right way to describe it.
That's right.
Yeah. Maybe we can break down. So there's all these different architectures that you're describing. This hybridization of all these technologies into these compact units or different system architectures. Tell us, maybe help us understand like what some of the options are in this space. What are some of the different architectures that you've been looking at?
Yeah, from the various projects we've been working on, we kind of define different options. Typically for compact machines, which are electrifying fast. These are showing lighter duty cycles, and in general, battery electric architectures are prevalent. So for such machines, we mainly are working on two types of architectures: the full electric ones with electric wheel drives or electrified axles, or the hybrid electrohydraulic architectures, which are combining electric power with highly efficient four-quadrant hydraulic systems that enable energy recovery. When it comes to heavier machines, we think that series hybrid will prevail to drastically reduce the CO2 emissions while still meeting the end user range expectations, because those are much more, let's say, need more energy and power in their daily job. Finally, in parallel, we also see a kind of general shift towards more decentralized and power-on-demand architectures that overall improve the efficiency of the system.
Yeah, that really makes a difference, doesn't it? That, rather than running, constant flow through a pump that you only tap into when you need it, now you're only creating flow at the point of actuation when the load demands it, right? That's really kind of the concept behind these compact units, right?
Yeah, that's correct.
Yeah, it's a fascinating and interesting development, and it's really creating some of those. The talk, as I mentioned, that you gave at the ConExpo trade show focused on one of those, an example, if you will, of that technology. I think you call it an electric wheel hub, if I remember correctly. Did I get that right? And can you describe some of the benefits and use cases of that technology?
Yeah, that's exact. We are quite proud about this development, which is our e-wheel, which is typically what we call as a generic term an EDU, electric drive unit. So that's a very good example of the integration and the mechatronic integration of the various techno bricks like electric motor, the mechanical transmission part, the power electronics, which include the control system of the electric motor and the overall functional safety into one single unit. Our first size of e-wheel is particularly relevant for compact construction equipment and compact equipment in general. And that's those machines are actually adopting electrification very quickly. And this is why we focused initially on this size of wheel drive. The concept itself brings several benefits for the machine designer: compact and easy integration, simplification of the overall machine architecture, fully compliant subsystem, which is really streamlining the machine compliance process for the OEM. Not only it brings advantages for the design phase, but also in the production, thanks to simplified supply chain, reducing the number of assembly steps and the production times. At the end, also, finally, the end user sees benefits with those, let's say, mechatronic solutions, thanks to a higher performance on the machine altogether, increased machine range, thanks to higher efficiency transmission systems, improved vehicle maneuverability and control, thanks to wheel drives, which generally enable to have a lower center of gravity on the machine, as well as maybe some low cabin, which enables to drive the machine into narrow spaces.
Yeah. Well, as you're saying, there's a lot of advantages to that kind of approach, that compact system approach. We'll continue with our guest in just a moment, but first I want to tell you about an opportunity to engage in the future of fluid power technology. Two of NFPA's most active committees are our two technology task forces, one focused on mobile applications of fluid power, the second on industrial applications. Each of these task forces work on a series of projects that help us better understand the technology trends in these sectors and help us develop the resources and connections that will be needed to keep fluid power positioned as an actuation technology of choice on both mobile and industrial platforms. The Mobile Task Force publishes a series of reports. Their latest was on ways to design more energy-efficient fluid power systems for mobile equipment with electrified prime movers. The Industrial Task Force also publishes reports. Their latest was on ways to minimize and prevent leaks in fluid power equipment. And they have also completed a year-long project that created an independent technology roadmap specifically for fluid power in industrial applications. All of these resources are accessible on our website at nfpa.com/technology reports. But more important is your ability to participate on and engage with the technology professionals that serve on these task forces. New working groups are forming now around the use of sensors and data analytics in fluid power systems, as well as many other cutting-edge technology advances. These task forces are a great example of NFPA's effective forum in action, with NFPA members across the supply chain and an increasing number of their OEM customers actively engaged in creating the technology strategies that help all of their businesses grow. To learn more and to get involved, contact me at elanke@nfpa.com. I mentioned the white paper that NFPA published in the introduction as well, and that white paper talked about thermal considerations. You mentioned that as well earlier in our conversation, and that, despite all of those benefits that you described, becomes a real challenge, doesn't it, in trying to manage the thermal considerations on these machines. What are some of the key considerations that Poclane is looking at as the electrification trend increases in that space?
Yeah, this is definitely something which is quite different from the traditional hydraulics we are used to work with.
Right.
The electrical components definitely have, let's say, thermal behavior needs to be taken into account when doing the sizing of the solution.
Mm-hmm.
So the proper sizing is really critical. We need to match the motor to the real duty cycle, not just the peak power. We need to understand how the machine behaves, how frequently it goes to peak power requirement, what is the continuous power, and to manage the thermal behavior, especially under the continuous load, but also making sure that while being on the continuous load, you will still be capable of accepting the peak power requirements of the required frequency. So all in all, it's understanding really in intricate details the duty cycle of the machine to ensure that the sizing that we do is appropriate, and to ensure that the system operates in its optimal efficiency range.
Yeah.
This is where really system level control and real-time monitoring also becomes essential with having real data and sensors into the system. Off-highway machines, we can say, are also characterized by so many different use cases and load cycles that even though you may characterize one which we think is representative of the typical usage of the machine, it may be, that some instances the machine will be used differently.
Yeah.
And so they are operating in so many different environments, countries, that at Poclane, we think that opting for liquid-cooled systems is generally a very good idea because the machine and its electric system then always operate under controlled conditions, ensuring a very good operator experience. Derating happens in those cases only on very rare occasions when you are using liquid-cooled systems.
It sounds like, a lot of these are like, as you're describing, these are new ideas or new applications to the fluid power environment. And I think if I remember from your talk, you talked about learning lessons from outside the industry, and particularly the automotive industry, providing some inspiration for how to approach some of these technical challenges. Can you talk a little bit more about that, about what some of those parallels are?
Indeed. When we look at the electrification, for sure, the automotive industry has been really ahead of the shift into the electrification for off-road equipment. So they went through the learning curve that we are going through now.
Right.
Obviously, the application is quite different in terms of duty cycles, in terms of ruggedness of the components. But nevertheless, you can still learn from, I would say, what the automotive industry has come up in terms of conclusions and ideas. So we can use some of this information, which is coming from high volume electric motor and inverter design choices which have been made, or thermal management strategies. Functional safety and software architectures also, and all the standards which are related to the automotive requirements are also a source of inspiration of what needs to be done to secure the systems that we offer to our clients. However, as said, off-highway machines are still very different in terms of duty cycles and variability, so we obviously need to adapt those concepts rather than just copy them directly.
Yeah.
That's why during our development processes, of the components, transmissions, and solutions, we go through extensive testing in real life usage of machines that we electrify with our components, get used into real conditions by end users, so that we can really ensure the developments and all the software control characteristics are meeting the expectations.
Sure. Yeah. Do you think there are other places, other industries that fluid power should be looking at to drive inspiration from, or to, as you say, adapt some of these existing solutions to our new environment beyond automotive?
Yeah, I guess beyond automotive, we see that there is a lot of, I would say, interest in the electrification, obviously in industrial automation systems, which have been there for a long time.
Right.
Aerospace, which is also looking at electric solutions, energy systems. Marine applications also is quite inspiring, and especially in the management of high continuous power requirements. And we believe that innovation often comes from cross-industry thinking. We try to avoid the syndrome of not invented here solutions,
Right.
and try to really be open-minded when we consider, new avenues and new developments. That's also one of the reasons that was always in our mind when we decided to build our e-mobility organization, by integrating expert teams that were exposed to various industries. And the origin of the teams that now make up the Poclane e-mobility organization bring a lot of strong cross-fertilization for the development of our new products.
Yeah. And the aerospace is an interesting case study, if you will, for this environment, because if I understand it right, I mean, they've had electrohydraulic actuators, compact units in aerospace for a long time. I mean, that's kind of where that technology was pioneered, wasn't it?
Yeah, that's correct.
Yeah. So what are some of the, I mean, as you said before, it's not as simple as just taking the component from one industry and slapping it in the other one. Are there other considerations when you try to make that change or adapt that technology?
The real value actually comes from system integration.
Yeah, right.
Electrification, hydraulics, controls, and software must really be designed together, not as separate components. The sensors feed real data, real-time data to the system. Control algorithms optimize the performance. The actuators, whether hydraulic or electric, deliver the required function. But all these needs to be synchronized in a proper manner to maximize efficiency and user experience. And so this is really there that you have to put a lot of care on how the whole combination is organized.
It's really a full systems level perspective that you're bringing to the environment. What are some of the key considerations when you make that perspective, when you take that perspective?
At system level, key considerations include energy efficiency across the full duty cycle of the machine. Of course, as mentioned already, thermal management is typically something that we have to be very careful about. Functional safety and compliance of the system, since we want to deliver our customers with a partly completed machinery and a certificate of incorporation, which really eases the following steps of the compliance process for them. So we put a lot of efforts into ensuring that our systems meet the functional safety regulations. And of course, ease of integration is something that we consider as really important, making our systems very easy to integrate, not to be a burden with a lot of calibration between components. So having a really ready-to-use kind of plug-and-play approach is really where we put the emphasis in the development phase. And of course, total cost of ownership, you still need to provide a system that is acceptable in terms of price positioning to the market.
That's great. Yeah, this has been a fascinating conversation, Philippe, and I appreciate everything that Proclaim is doing in this space. It's a very complex and multifaceted approach that you're describing, and there's a lot of considerations going. I always like to end the show by asking about the future. So, what I'm curious from your perspective, look into your crystal ball 10 years from now. Like, what do you think we're going to be seeing in this space? What's the future of electrification look like?
Key drivers we think are clearly, obviously, efficiency, productivity, and user experience, while keeping total cost of ownership under control. The evolutions into the technologies, into the battery technology, will certainly fast track, the adoption of electric machines in the market. Autonomy will also probably act as a catalyzer of vehicle electrification, because when talking about autonomy, you talk about system engineering, about interconnecting systems, and there is a lot more software control involved, which links back to electric actuation most of the time. We expect that the battery electric solutions will still dominate the compact equipment market. Hybrid architectures seem to remain, I think, for quite some time, the best option for higher power machines. Another trend that we see is certainly the adoption or increasing adoption of high voltage systems, even for lower power solutions, and potentially even into compact equipment, since it brings some real advantages into fast charging infrastructures and enabling an availability of the machine, which is increased compared to low voltage systems. We also see that more and more integrated functions, like integrating the various technologies into standalone subsystems like e-steering, e-PTOs, e-compressors, electric drive units, will be more and more used on the machines instead of separate components. Another point, which is more related to how OEMs work with their suppliers, is we see the need also for strong partners capable of delivering complete systems, including software and safety. So we think that OEMs will look for those types of companies which are really capable of making the combination of these competences and support them into the development process of the electric machines. That's exactly where Proclaim is positioning itself as a transmission partner, providing all these support services, not only the products.
That's one of the themes I've been hearing more and more as we do this show, the partnerships that need to be developed between the suppliers and the customers in order to make these technologies work effectively on the machines. And as you said, it sounds like that's going to continue to accelerate as we move forward into the future.
I think we need closer relationships and project management when developing an electric machine. It's not, the simple specify and buy component approach. You really need to review the machine duty cycle into details. You need to understand what is the ecosystem that your system will interact with, define the interfaces and the job split between what the OEM teams are doing and what we are doing, so that we can really provide the level of support and ease of integration of the system into the machine ecosystem.
All right, well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Philippe Reynolds of Proclaim Hydraulics, who has been my guest on the show. If you'd like to connect with Philippe, learn more about the exciting work happening at Polk Lane, the best way to do that is by his email address, and we'll put a link to his email address in the show notes for this episode. And make sure to check out NFPA's full white paper on this topic. It's called Energy Efficiency Gains from Electrified Hydraulics. And you can find that on our website, nfpa.com/technology reports. Look under the energy efficiency section. And remember, if you like our podcast, and we hope you do, please follow us on LinkedIn. You can find us there at the National Fluid Power Association. And please keep sharing those interesting and innovative uses of fluid power on social media with our hashtag #OnlyFluidPowerCan. We truly want to hear from you about the kind of topics that we should be addressing on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.